Imagine you're settling in for a flight, maybe a long one. You're cruising high above the clouds. Everything feels completely normal. Maybe you're even relaxing.
Yeah, the usual routine.
Exactly. Then you notice it. Just a faint smell, maybe a bit acrid, or something sharp, chemical-like, not coffee, not food.
Something out of place.
Right. And maybe you see it too, just a tiny wisp of smoke near a vent. It's subtle, but it's definitely there.
That's the moment where everything changes.
It really is.
Oh.
And that exact moment, that unexpected smell or sight of smoke, is what we're doing a deep dive on today.
We're looking at the procedures for smoke or fumes on an Airbus A320 or A321.
Yeah, our mission here is to give you a clear picture, sort of a shortcut, to understanding what pilots do when this happens: smoke, fumes, or that specific avionics smoke alert.
We'll unpack how they detect it, how they figure out where it's coming from, and how they manage it.
Exactly. We're pulling back the curtain on the decision-making, the systems involved, and some, frankly, surprising details that keep everyone safe.
And what's interesting is how it starts. It's not always a loud alarm right away.
Really? You'd think with all the tech.
Well, the tech is crucial, obviously, but sometimes it's just the crew's senses first. They might smell something off or see a haze before any computer alert, before the ECAM warning even shows up.
You mentioned ECAM there. For listeners who might not be familiar, what exactly is ECAM on an Airbus? Why is it so important here?
Oh, right. Good question. ECAM stands for Electronic Centralized Aircraft Monitor. Think of it like the plane's main computer display for system status and warnings.
Okay.
It's constantly monitoring everything. And in an emergency like smoke, it doesn't just flash a warning. It actually tells the pilots what's wrong and gives them the checklist, the steps to follow, right there on the screen.
Because it's interactive.
Exactly. It's their primary tool. And it's not just avionics smoke. Other warnings like cargo smoke or lavatory smoke can also pop up.
Gotcha. So it's way more than just a simple warning light. It's like an interactive emergency guide.
Precisely.
But you also mentioned the human senses being key, sometimes even faster than the ECAM. Our sources talked about some really specific smells pilots are trained to recognize, like a detective kit almost.
It really is. It shows how much perception matters, even in such a high-tech environment. Like if they smell something like orange peels.
Orange peels. Seriously.
Yeah. Strange, right. But that specific smell could mean a toxic leak of rain repellent fluid, or maybe a smell like pine needles. That could be a non-toxic leak, maybe from a different system.
Wow.
These aren't just random guesses. These specific odors are known indicators, part of their training. It helps them narrow things down fast, sometimes before the instruments even confirm it.
That's incredible. Human senses working alongside the tech. So, okay, the smoke or fumes are detected either by sensors or smell. How fast does the situation escalate?
Instantly. The priority shifts immediately. The QRH, the Quick Reference Handbook, which is their go-to for immediate actions in emergencies,
Right.
It has one very clear instruction: land ASAP.
ASAP, as soon as possible.
Exactly. Not when convenient. It means find the nearest suitable airport and get down now. Time is absolutely critical. Every second counts.
That really drives home the severity. Land ASA. So what are the very first things the pilots actually do in the cockpit?
Okay, first priorities are protecting themselves so they can manage the situation. So oxygen masks and goggles go on immediately, set to 100% and emergency flow.
Right. Breathing is key, but also vision, I guess.
Absolutely. Clear vision in smoke and maintaining focus under that pressure. At the same time, they're hitting switches for ventilation, specifically ventilation blower override and ventilation extract override.
Override.
Yeah.
What does overriding those ventilation systems achieve?
Yeah, override. Normally, the ventilation system circulates air. With smoke, you might want to stop that spread or maybe try to push the smoke out of the cockpit.
Oh, okay.
So overriding gives them manual control over that specific airflow in the cockpit, trying to contain or clear the immediate environment.
Makes sense. Containing the threat locally first. What else happens immediately to manage the cabin?
They'll also cut power to the CAB fans and the GAA NPIB power supply.
Why cut the cabin fans?
You don't want to circulate smoke through the whole cabin, right? And
Yeah.
you also want to reduce potential ignition sources if it's an electrical issue. Turning off fans helps contain it.
Gotcha.
And the passenger side GNAS seatbelt, no smoking, they all go on. That signals to everyone that something's happening. And critically, they establish CKPT cabin comm.
Cockpit to cabin communication.
Vital. They need to talk to the cabin crew immediately. find out what they're seeing, smelling, the smoke density back there. It's all part of that initial multi-layered response that happens within seconds.
Okay, so masks on, ventilation handled, initial containment started. Now comes the detective work you mentioned, finding the source. That sounds like the trickiest part.
It really is the core challenge.
Yeah.
Because where the smoke is coming from dictates the entire next set of actions. The procedures are totally different depending on the source. For example, if they see smoke coming out of the air vents, that points strongly towards aircon smoke, an issue with the air conditioning packs.
Okay.
Or if it happens right after an engine issue or an APU issue, the auxiliary power unit, then they're thinking bleed air leak, the hot air taken from the engines.
And the avionics smoke alert is pretty self-explanatory, I guess.
Yeah, that one points directly to the electronics bays. But sometimes, if a specific system was already acting up and then smoke appears, well, that system becomes suspect number one.
Makes sense.
And again, sometimes they might smell smoke from the avionics or maybe the forward galley before the ECAM alert even triggers that human element again.
Which brings us back to that smell detective kit. You mentioned orange peels and pine needles. What other smells are they trained for?
Well, the training covers quite a few, like an acrid or general burning smell. That often points to electrical equipment overheating or maybe an engine oil leak finding a hot spot. A distinctly chemical smell could be contaminated bleed air getting into the cabin supply, or maybe the APU ingested something nasty like de-icing fluid.
And are there less pleasant smells too?
Oh, yeah. A foul odor usually points towards, the lavatories. System malfunction there. And a really specific one is the smell of skydrol.
Skydrol? What's that?
It's the hydraulic fluid used in most commercial jets. It has a very unique kind of oily phosphate ester smell. If they smell skydrol, they're immediately thinking engine hydraulic system leak.
Wow. So recognizing these is a key skill.
Absolutely. It can save crucial time in diagnosing a complex problem. It's this blend of sensory input and deep systems knowledge.
And the cabin crew are feeding information back too, right? They're part of this detection process.
Definitely. Communication is constant. The flight crew needs reports from the cabin, smoke, density, color, locations, smell back there. It all helps build the picture.
Okay, so they're trying to pinpoint the source. What's the overall strategy then? Fix it or flee?
Kind of both, sometimes at the same time. The basic idea is if the source is obvious, reachable, and they think they can put it out quickly, like maybe a small fire in an oven,
right,
then they'll try to isolate it, cut power, use an extinguisher. But if the source isn't immediately clear, or if the smoke persists, or it just feels unmanageable, then a diversion is initiated immediately. Head for the nearest suitable airport.
And that usually involves descending. You mentioned descent to FL 100 Miyamura.
Yes. Descending to flight level 100, that's 10,000 feet, gets them down to an altitude where oxygen masks aren't strictly needed for everyone, and it prepares them for landing. Miyamura just means the minimum en route altitude or minimum obstacle clearance altitude, basically, the lowest safe altitude for wherever they are, ensuring they don't hit anything, especially if they're off their planned route. Planning that descent is key if the source isn't quickly contained.
Got it. So let's walk through a specific scenario. Say they suspect aircon smoke fumes, air conditioning system. What happens?
Okay, for suspected air conditioning smoke, it's very methodical. First, they'll shut off the APU bleed air supply. They might adjust the ventilation overrides again, maybe back to auto if the smoke seems to lessen, or keep them on OVD if it's still bad.
Okay.
They also turn off something called the cargo AFT isol valve.
Why the cargo valve? What's that got to do with air conditioning?
It's a clever step to avoid confusion. Sometimes smoke can drift into the cargo hold from somewhere else and trigger the cargo smoke detectors. By closing that valve, they prevent a potentially false cargo smoke warning from distracting them while they're dealing with the real source, which they suspect is the air conditioning.
Smart, keeping the warnings focused.
Exactly. Then they start shutting down the main air conditioning units, the packs, one by one. Turn pack 1 off. Does the smoke stop? No. Okay, turn pack 1 back on, turn pack 2 off. Does it stop now?
Process of elimination.
Precisely. If turning off a specific pack clears the smoke, they've found the culprit. They can then try to restore the system using just the good packs. It's all about isolating the fault while trying to keep the cabin pressurized.
Okay, and what if the smoke seems to be coming from something in the cabin? Like galley equipment or something?
Right, if it's suspected cabin equipment smoke, then first, EMER exit lights go on, just in case. And power to commercial systems, basically non-essential cabin stuff, galley power, entertainment, gets turned off.
Okay.
Then the cabin crew undertakes a search isolate mission. They physically look for the source, maybe use a BCF extinguisher if they find it and it's appropriate. Once it's isolated and dealt with, and if it's safe, commercial power might be restored.
So empowering the cabin crew to handle local issues, that makes sense. But the big one, what if they can't find the source? Or they strongly suspect it's avionics or electrical deep in the aircraft systems? That sounds much more serious.
That is definitely a more severe scenario. If the source remains elusive, or if it's pretty clearly electrical or avionics, especially if that Avionics Smoke ECAM alert is triggered, they have to consider moving to the electrical emergency configuration.
Right. You mentioned that earlier, elec-AMER config. It sounds intense. What does that actually involve?
It's a huge step because it fundamentally changes how the aircraft gets power and how it flies.
Yeah.
You're essentially shutting down the main electrical network. Switches like EMER-elec Gen 1 line off, the APU Gen off, Gen 2 off, they get switched off. Major power reduction.
Whoa. So what powers the essential stuff?
That's where the RAT comes in the ram air turbine. It deploys automatically.
A little wind turbine.
Exactly. It pops out from the fuselage, the airflow spins it, and it generates emergency electrical and hydraulic power for the absolute critical flight controls and instruments. It's a lifesaver.
Okay, so they're flying on this emergency wind power. How does that affect the actual flying? You said it was profound.
It is. Because when you enter elec-AMER config, you lose the normal flight control laws and all the associated protections.
Normal laws?
Yeah.
What does losing them mean for the pilot?
Okay, think of normal law like having really advanced stability control and anti-stall systems in your car. The computer helps keep you safe, prevents you from doing anything too extreme.
Right.
When you lose normal law, the plane reverts to LOTN law, alternate law. The protections are reduced, the pilot has more direct control, but also more responsibility to keep the aircraft within safe limits. And then, when they lower the landing gear, it shifts again down to direct law.
Direct law. It sounds like basic.
Pretty much. It's almost raw control. The pilot's inputs on the side stick go almost directly to the control surfaces, ailerons, elevators, rudder, with very minimal computer filtering or protection. It requires pure flying skill. It's a massive shift from the usual computer-augmented flying. Really tests their training.
That sounds incredibly demanding. What about communicating or seeing what's going on with limited power?
Yeah, comms are limited, usually just one VHF radio, maybe one HF and one ATC transponder. And they'll be squawking 7700, the universal emergency code.
Letting ATC know immediately.
Absolutely. And the ECAM displays, the lower screen usually goes blank. Critical status info gets crammed onto the upper screen. And there are new limitations they need to maintain at least 140 knots airspeed for the RAT to generate enough power.
A minimum speed.
Yeah, and the maximum speed is also usually restricted, often to around 320 knots, because the handling is so different without the normal laws.
So even in this drastically reduced state, they're still prepping for landing. How do they manage needing systems like brakes if the power is so limited?
Great question. They plan meticulously. There's a procedure where just before landing, maybe 3 minutes or 2,000 feet above the airfield, they might briefly bring one of the main generators back online.
Oh, but wouldn't that risk restarting the smoke?
Exactly the risk they're balancing. They do it for the absolute minimum time needed to get essential landing systems back, like normal braking and nose wheel steering, then potentially shut it down again. It's a very calculated risk, prioritizing a safe landing over potentially re-aggravating the smoke source for those final moments.
That balance is just cool. Wow. Okay, so they've tried everything, maybe even gone into electrical emergency config. But what if the smoke just won't stop? It's filling the cabin, becoming, as the procedure says, the greatest threat. What now?
Right. That's when the specific removal of smoke fumes procedure is actioned. The focus shifts entirely to just getting breathable air in. And the approach here depends crucially on what they think the fumes are.
How so?
If they suspect fuel vapors, well, that's incredibly dangerous because of the explosion risk. So in that specific case, CAB fan-S are turned on to try and disperse the vapors, but the packs, the main air sources, are turned off to avoid introducing an ignition source or more air into a potentially flammable mix.
Okay, crucial difference for fuel. But if it's not suspected fuel vapor?
Then it's the opposite. CPAM's off to stop recirculation, and pack flow set to HHI to try and push the smoke out with maximum fresh air from the packs. The primary goal becomes ventilation, ventilation, ventilation.
And the best way to ventilate is using outside air, right? Ram air.
Exactly. So they'll likely be descending, again, to that FL-100 Miyamura. Then they hit the ram air switch on. This opens a valve to let outside airflow directly into the cabin. They might even manually force the outflow valve open more using manual cabin pressure control, cabin press mode, cellman, man via CTL full up, basically trying to force the bad air out and suck fresh air in.
So they're actively managing the pressure differential to flush the cabin.
Precisely.
But what if even that doesn't work? The smoke is still overwhelming. Is there anything else?
There is one final, very extreme measure listed. If the smoke remains intolerable, the procedure allows for opening the cockpit door slightly and the pilot monitoring sliding window.
Opening a window at altitude.
Yeah. It's a last resort. The noise would be absolutely deafening, wind blast. They explicitly warn the crew they'll need to pay particular attention to visual warnings because they won't hear any auditory alerts over the roar. It just shows how critical clearing the air becomes.
That is truly a last-ditch effort.
Yeah.
It really underscores the severity, and ultimately, all these procedures point towards one goal.
Getting the plane on the ground safely. The procedures constantly reiterate. If the situation becomes unmanageable at any stage, an immediate landing is the priority. That could mean accepting an overweight landing or landing with a tailwind, performing a ditching on water, or even a forced landing off airport if absolutely necessary. Safety of life overrides everything else.
What an absolutely fascinating and sobering deep dive. We've gone from that first whiff of smoke through the detective work, the systematic shutdowns, the drastic electrical emergency configuration, extreme ventilation efforts, all the way to planning for potentially very unconventional landings. It paints a picture of incredibly detailed, structured protocols.
It really does, and it highlights the sheer complexity involved and the incredible amount of training pilots go through to handle these things calmly and methodically under immense pressure. You know, it's a real testament to the safety culture in aviation, both in the design of the aircraft and the skill of the crews.
It makes you think, doesn't it? We have all this amazing technology, sensors, automated alerts, yet we still rely heavily on fundamental human senses like smell and core piloting skills in these extreme scenarios. What does that make tell us about flying modern aircraft? Maybe it suggests that no matter how advanced the tech gets, that constant vigilance, that human judgment, and that deep understanding learned through rigorous training remain absolutely essential, especially against something as basic yet potentially devastating as an unexpected smell at 35,000 feet. Something to definitely ponder.